Hi. By the time you see this video, you will have had a chance to have created your own ERD based on the project specifications that I gave earlier. And so, as I told you before, I was going to let you determine as best you could how to design the database, and then I would provide you with some feedback. So that's what I'm doing right now. And as we look at the ERD, hopefully some of these entities look familiar, and I will walk you through what my design consists of, and then you can compare it with what you've done. So a place to begin, I suppose, would be looking at probably the most apparent entity in the entire design, and that would be the book entity or the title entity. Okay, so we could go either way, but as we had discussed previously in the bookstore example, I'm distinguishing between the intellectual aspects of a book and the physical aspects of a book by breaking it down into two separate entities. So I'm going to begin right here with the book entity, since we have some background for this and know what to expect. So imagine there being something that we call a book, and we know what it looks like. We know that it could have a number of different attributes, to include things like the condition of the book, and perhaps whether or not it's in hardback or softback. But we have a physical book then that would be stored on the faculty person's shelf, and that brings into play the entity called faculty. So considering the binary relationship between these two entities, we would say that a instance of a faculty, so we're going to pretend that this is being done in the computer science department. We'll just use me as an example. So Chuck Koontz as a faculty member, if we consider that instance or that row in the faculty table eventually, then Chuck Koontz could have many books, but a book, a physical object that Chuck Koontz, that belongs to Chuck Koontz, then would relate back to just one faculty member. So that should be fairly clear. And then if we follow the relationship from book to title, again, two entities that we're already familiar with from another problem, a instance of a book, okay, so if I go to my bookshelf and pull off a book and hold it up and examine it, that book will have but one title. And if I put the book away and then consider that title, there could be multiple books. So in fact, on my bookshelf, sometimes I have multiple copies of a book, and as we would look at modeling the data storage of this problem, then the title would be stored away eventually in a table one time, and it would be then related to each instance of the physical book. So again, a title could be associated with one book, but a book's only going to have one title. And then what I provided in addition to the title was information about the publisher. So a publisher like McGraw-Hill, for instance, if I just use them as an example, McGraw-Hill, perhaps their website address, their URL, perhaps a contact person even would be stored here in the publisher entity. Those would all be attributes associated with the publisher entity. And if we consider the binary relationship here between publisher and title, a publisher could have many titles that they sell, and a title then would relate back to but one publisher. Okay, so and again, I think you can imagine the kind of attributes that eventually we might want to add to this publisher entity. And one of the other requirements of the project was to design the database so that users of the database could comment on books that they check out from the faculty. So if a student checks out a particular book and reads it, and on page 71 finds something that's relevant to what's going on in the class, they might, make a comment, and then that comment could be stored, and that comment would be associated with but one title. Okay, so if a student makes a comment about something on page 71, that relates back to one title. On the other hand, if we take that title, there could be many comments associated with it. So if it's checked out over, many different times, then several people could comment on it, and that title could have associated with it many different comments. So again, one-to-many relationships showing up there. Now we're going to get into a little bit more complicated area here. I think I'll go this direction with title and author. Okay, so if for a moment you can imagine that this bridge entity doesn't exist, we'll consider the natural relationship between title and author. So an author, again, is a people type entity, and we know what a title is. So an author could create many titles. You've seen authors publish, or authors that whose names appear on many different books, maybe. So an author could be associated with many titles, and a title could be associated with many authors. It's not at all uncommon with textbooks, if you look at the cover, for there to be multiple authors, where the people writing textbooks, usually college professors, then collaborate and work together. So a title could have associated with it many authors. So in the real world, we'd be looking at a many-to-many relationship between title and author, and since that can't be implemented directly, then we would decompose that many-to-many relationship into two, count them, one-to-many relationships. And again, the one will be on the side of the original entity, and the many will be on the side of the bridging entity. And in this entity, at a minimum, we have to store the primary keys from the parent table. So if author ID is the primary key of the author table, I would have to store author ID in the bridge table as a foreign key. Also, I would have to store title ID as a foreign key in the bridge table. So at an absolute minimum, there would have to be two columns in this table, and individually the columns would act as foreign keys that point back to rows of data in the parent table, and collectively they could be used as a primary key. We could create a composite key by using the combined value of each column on a particular row. Now, I had mentioned earlier that was done, oftentimes in the past when storage was more expensive, but nowadays what we would probably do under these circumstances is go ahead and create a third column and designate it as a primary key, make it a surrogate key or an auto number column, and then we could use one column as a primary key, and the two columns that would that we discussed previously would be used strictly as foreign keys. And if you can think of anything else that might be stored at the intersection of author and title, then that could be added. As I think about this, nothing occurs to me, so I would probably treat this strictly as a bridge table, just as a table that has the sole purpose of decomposing that natural many-to-many relationship. Now, if we go over to the relationship, the natural relationship between book and borrower, again, the problem calls for designing the database so that it can keep track of books that are borrowed from other people. And so you'll notice that I show this diamond shape in the entity here, and I call it loan. But as I discovered this entity, here's how I discovered it. It occurred to me that there was going to be this entity called borrower. Okay, so that could be a student or it could be a faculty person. Someone who wants to use the book, then we don't distinguish between student and faculty. We just call the person borrower in that context. If we consider that entity and we consider the book entity that we've already discussed, the borrower wants to somehow take a physical copy of the book. Okay, so the relationship's going to be with the physical copy of the book, not the intellectual properties. And so if we ignore this entity here for the moment, then we could consider the natural way it occurs in the real world an instance of borrower. Okay, so we have person A wants to borrow a book, okay, and a borrower could borrow one book, or they could borrow many books. If you imagine what the scenario is like when you check out a book at the library, oftentimes you'll check out multiple books. So a borrower could borrow many books, okay, and if we look at the reciprocal, then a book could be borrowed by many different people over time. So we have a many-to-many relationship naturally occurring. So we're going to decompose that many-to-many relationship into two one-to-many relationships. Again, putting the nature of the relationship in place such that this bridging entity is on the many side of the relationship for both of these. And so when a borrower needs to check out a book, we would record information about that in the loan table. So things that we might want to include there would be a date stamp. Okay, so imagine if you're checking out a book at the library, more than likely you're going to have a date stamp that indicates when the property was checked out. And you might want to also have a date stamp that specifies when the property is to be returned. So a second column could be added there. And another potential attribute might be the condition of the book. So whoever's checking the book out might want to make some general observation, and they may want to have just a text field that says books in good condition or something like that. And so once it's returned, that field might need to be checked to make sure that when it's returned it's in the same state. So if I were designing this database, I would probably put in here in this loan entity a auto number field, so that each row, which represents a checkout transaction, each row can be numbered automatically by the database management system. So we'd have a surrogate primary key, and then we would have to store as a foreign key the book's ID and the borrower's ID, and then additional data fields of when the book was checked out, when the book is to be returned, and what condition the book is in. And really, because we're adding those additional fields, this takes on a new life of its own and would really be an association entity as opposed to just a bridging entity or a junction entity. And then finally, something that's commonly done with people type entities is to associate phone numbers or email addresses with them, so we could have also had an email address table as well, but we'll just consider phone number. So for anyone that borrows a book, we want to have some way to track them down, call them if they don't return it in time. So we would want to store a phone number, and it may well be that if we wanted to store multiple phone numbers, rather than trying to deal with a multi-valued attribute in the borrower table, we would just take that entity, recognizing that it's multi-valued, and spin it off as a child table. Again, it would be on the inside of the relationship. And then for each borrower, we could store one or more telephone numbers. And if a borrower ever needed to add a phone number, we could very conveniently add a row in the phone table without having to change the physical structure of the borrower table. Okay, so I've also included some cardinalities here, and we had looked at those, I think, previously. I'm going to zoom in here real quick so I can see this a little bit better. And so if you look at the cardinalities, and I'm just going to look at the one for borrower, and then you can consider the cardinalities that I've mapped in elsewhere. But these cardinalities just add a little bit more detail to the nature of the relationship. They show the minimum and maximum limits on the relationship. So this cardinality that reads one and in as in many, is saying that a borrower must, at a minimum, provide one phone number. So that's what the one is. That's the minimum cardinality associated with that side of the relationship. And at a maximum, they may have many phone numbers. On the other hand, if we consider the minimum and maximum limits on the relationship from the standpoint of phone, then a phone number is going to be associated with one borrower and only one borrower. Okay, so you would apply that same kind of logic elsewhere. And cardinalities, although not absolutely required, are very useful in terms of adding additional detail and understanding the nature of the problem more completely. So that is my example of an ERD, and you can compare that with what you've done. And again, there's no there's no absolute correct way to do this. Some ways maybe more work better than others, but this was my representation of things, and I believe I've addressed all the issues that I originally laid out in the project specifications. So I hope that was helpful, and that concludes my analysis of my database design for the Computer Science Department Distributed Library.